This video is about mass airflow sensors and how they're pretty cool. So what are mass airflow sensors? Mass airflow sensors are used to meter the amount of air coming into an engine so the ECU can properly inject the correct amount of fuel into the engine. And it's arguably the single most important sensor for making the engine run correctly. And when tuning an ECU, it's the main parameter that's changed to make sure that the air-fuel mixture is correct. So what is an ECU? The ECU is the brains behind modern fuel injection systems. On a most basic setup, you'll have a manifold air pressure sensor and or a mass airflow sensor, a crank position sensor, an oxygen sensor, throttle position sensor, and a coolant temp sensor. This is the bare minimum that the computer needs to read in order to inject the correct amount of fuel and timing for the engine. Older engines like Honda, they just use a map sensor along with everything else, and older Ford and GM style ECUs, they just use a map sensor and no map sensor. So it's kind of an either or thing, and it doesn't really matter. Modern systems, they use a lot more to control the engine with gasoline direct injection. It has mass airflow sensors, 2 map sensors, multiple fuel pressure sensors, and yeah, it gets a lot more complicated. So in this video, I'm just going to be covering basically the bare minimum. So there are 2 main styles of mass airflow sensor, mechanical and hot wire. Mechanical, I'll cover both of them, but mechanical is something like you would find in an older BMW, maybe like an E30 or something like that, Mercedes. And then hot wire came after the mechanical, and it's what I mentioned about being in like the older Fords and stuff like that. So the mechanical style literally just has a flap inside of the body, and as that flap opens, it turns a potentiometer and changes the resistance, therefore the voltage that's being sent to the ECU. So the mechanical can be modeled pretty much like this. Just imagine the flap is directly connected to the wiper. So as the flap opens, the wiper moves across the resistive strip. It sends a signal to the ECU. Whenever there's low airflow, it'll be a low voltage. And then whenever it's maxed out, it'll send a 5 volts. And that tells the ECU there's more air. So you might be thinking, the density of air changes with temperature. So in a cold environment, the engine might run lean, and that could cause catastrophic failure. Do not worry. Both mechanical and hot wire style are paired with a temperature sensor. In this example, the thermistor, it's a positive temperature coefficient, but that's not always the case. It varies from basically what the ECU is expecting. And so whenever you have a setup like this, if you think about it, if the resistance was really low, you would get super low voltage. And if it was, or say it's approaching infinity, the resistance is extremely high, you're going to get a voltage really close to 5 volts. So that tells us it's hot. So, and it vice versa if it's not positive temperature coefficient. But yeah, that's how that works. Moving on to the hot wire mass airflow sensor. Fundamentally, it works the same. Whenever there's less air entering the engine, you'll send a low voltage, then a higher voltage up to 5 whenever it increases. It uses a hot wire and a thermistor to do this, and they're both positive temperature coefficient. Now, it is important they're not the same thing, even though they work fundamentally similar. The hot wire gains and loses resistance faster than the thermistor, and this is extremely important for how it functions. Looking at the circuit for this, you can see that you have 12 volts coming in, goes to a transistor. The H is for the hot wire, the T is for the thermistor, and then R, those are resistors. And then you can see you've got an op amp over here, and then the output voltage to the ECU labeled VC goes to the ECU, and that's what is that signal that's between 0.5 and 5 volts. Breaking down the circuit into smaller parts, we have the op amp over here, and you can see that it's used as a comparator. And so this is the ECU signal. It goes in here, and then this is VX. Basically what happens is whenever VC is greater than VX, you'll have an output, and then if not, then there's just nothing. The transistor, the way it works is simply put, whenever you have a current coming in here, think of it almost as a switch, and then the current from the battery that would be right here and the current that would be coming out of the op amp over here flows back into the circuit. So the mass airflow sensor works in a cycle. I'll go over that more later. And also remember that this is an example. So, VC could never be more than 5 volts. But what's happening right here is we're saying that VC is greater than VX. So I changed everything to where VC equals 2VX. And then when you plug everything in, you have uh, Vx is less, Vc is greater. And before I mentioned that it was important that the hot wire will cool down faster. And as it cools down, it's going to lose resistance faster. And that is demonstrated here, where the resistance of the hot wire is less than that of the thermistor. Now, don't forget, so now that VC is greater, right? In the original circuit, we had an op amp coming around over here. So basically what's going to happen is as soon as the voltage going to the computer gets bigger than this voltage over here, now there's going to be more current coming in to this system right here. What that in turn is going to do, more current flowing through the hot wire is going to heat the hot wire back up. And since the hot wire changes resistances faster, now the resistance is going to increase. And it's important to note that the hot wire is going to increase in resistance faster than the thermistor. So now that the hot wire is heated up and its resistance is increasing faster than that of the thermistor, in this imaginary scenario, we're going to say that the resistance of H, the hot wire, is double that of the thermistor. So solving this, what does that tell us? It tells us that obviously H is double, but what happens? Vx is going to equal, it's going to be higher than VC. So now that op amp that we mentioned before is not going to be letting any extra current into the system. So it'll allow the hot wire to cool down again. And this happens constantly in a cycle to output the right voltage for the ECU read. So why is this cycle important and why does it need to happen? This was something that was hard for me to wrap my head around at first, but hopefully this example will help you understand. So imagine it's a nice day and you've baked a pie and you take the pie out to your yard because it's too hot to eat and you just start blasting it with a leaf blower. The velocity of the air coming out of that leaf blower is going to stay the same, but your pie is going to keep getting cooler and cooler. We'll think about it the exact same way. As the air stays at a constant velocity coming through your car intake, you don't want that hot wire to keep getting cooler and cooler. You want it to stay at the same temperature so the resistance remains the same, giving you an accurate voltage based on how much air is coming into the engine. Considering a performance application, mass airflow sensors are better than manifold air pressure sensors in my opinion, because if you get 5 volts before you reach your max airflow, you can just put it in a bigger housing and then reprogram the computer. This has to be done often. I've done it before. And it's not really a big deal. Whereas a manifold air pressure sensor, whenever you hit that 5 volts, you're just out of luck and you have to buy a new sensor. Thank you for watching my video. And, if there was any wrong information or you just didn't like the video, please just harass me in the comments section. That would be greatly appreciated.